Okay, so for page 44, you'll go ahead and just cut out this template and paste it here. You don't need to title it because the title is already on the template. It's going to be Graphs of Polynomial Functions. And so you'll see some examples of graphs here that I have given equations. These are not the actual equations of these graphs. They're just ones that I made up. But they're going to be the general equations of what the graph would have depending upon the degree of the function. So for example, this constant function has a degree of 0. It's a horizontal line. And the degree is 0 because the exponent that would be on the variable here would be 0, and x to the 0 is 1. A linear function has a degree of 1, and a quadratic has a degree of 2. And so now we're going to focus on higher degrees in this unit. So I've got an example of a cubic function with a degree of 3, a quartic with a degree of 4, and a quintic with a degree of 5. As the degrees increase, you'll notice a few things. The first is that the x-intercepts, you have more x-intercepts. So in the degree of 1 for the linear, you'll notice you have 1 x-intercept. For degree of 2 for the quadratic, you'll notice you have 2, a cubic 3, quartic, quintic 4 and 5 respectively. That doesn't mean we're going to have exactly that number. These graphs could be moved up or down so that it has no x-intercepts or maybe 2 x-intercepts and so forth. So the degree is only going to tell you the maximum number of x-intercepts it can have, but it could have less than that as well. You'll also notice that you have more relative maxes and mins the more your exponent goes up or your degree goes up. So in the case of a quadratic, you have 2. In the case of you have 1, I apologize. In the case of a linear, you have none. In the case of a cubic, you'll notice you have 1, 2 relative maxes and mins. For a quartic, you have 1, 2, 3. And then for a quintic, you have 1, 2, 3, 4. So you actually notice you'll have less than the degree this time. So for the degree of 5 on the quintic, you had 4 relative maxes and mins. For a quartic, you had 3, even though the degree was 4. Again, this is the number that it can have at most. It doesn't have to have 3 for the quartic. It could have 2 or it could have 1. That's just giving you the maximum number that it could have. So for the notes on this page, we have that a polynomial function has at most n, which is going to be the degree of the function, real zeros. So again, it can have exactly n, but it could also have less than n depending upon if the graph moved up or down. The general form of a polynomial function is given here. You've seen this before in the past. And then the last note is the graph of a polynomial has at most n minus 1 relative extrema. Relative extrema is another vocabulary word. It just simply means relative maxes and mins. But these are also called turning points. And that is all for the notes on this page.